Hi, I'm John McBride.
I'm Joyce Poko.
Today we're carrying out 4 experiments. We're comparing physical properties of different substances to see how these properties are related to the strength and type of intermolecular forces in these substances.
Let's make a start with evaporation. We'll use 4 different liquids: ethanol, water, acetone, which is the main ingredient of nail polish remover, and methylated spirit. We place 4 watch glasses on electronic mass meters. Then we zero the scale so that we can measure the mass of the liquids when we add it to the dish.
Now we add 20 ml of each liquid to each dish and record the mass of 20 ml of each liquid. Thereafter, we'll wait 8 minutes for the liquids to evaporate.
And now, we'll measure the mass of each liquid after 8 minutes.
I'm showing you the table of values that we obtained so that you can take it down. The last 2 columns of the table are for you to complete later. Just copy the mass before and the mass after, and then we will move on. You'll find that there are further questions about this experiment for you to complete on your worksheet. There is time set aside for you to answer these questions at the end of the video. So please move on now to the investigation of surface tension of liquids.
Surface tension is a fascinating property of liquids which allows insects to walk on water, supports a paperclip on the surface, and even allows us to overfill a glass of water. We'll compare surface tension of liquids by examining the meniscus of liquids and the shape of a drop of each liquid.
We will compare the following liquids: water, cooking oil, glycerine, acetone, and methylated spirits.
To see the meniscus more clearly, we're using a small measuring cylinder.
We add the same amount of liquid to each of the measuring cylinders, and then we take a closer look at the shape of the meniscus.
The meniscus can be concave or it can be convex. Or the meniscus can be almost flat or slightly concave or slightly convex.
A concave meniscus tells us that the liquid is attracted to the glass of the measuring cylinder, but it also has very strong attractive forces inside the liquid, which keep the molecules together very tightly.
So, a liquid with a concave meniscus has strong intermolecular forces between its molecules, and it has a high surface tension. A relatively flat meniscus tells us the surface tension is relatively low. Let's take a closer look at the meniscus of each of our liquids.
Here's the meniscus of water. Describe what you see. Cooking oil. What do you see? Here's glycerine. Describe what you see. Next we have acetone. And methylated spirits. Describe what you see.
Now we will place 1 drop of each liquid onto a glass slide and we'll examine the shape of each drop.
If the liquid is attracted to glass, the droplet will be relatively flat because the glass attracts the molecule of the liquid. Glass is a polar substance. It attracts polar molecules. If there's less or no real attraction between glass and the liquid molecules, the droplet will be more spherical.
We use a glass rod to pick up a couple of drops of liquid and we place one drop on the glass slide.
Let's start with water. Here we are. This is a drop of water on the glass slide. Draw its shape in your table of results.
You don't need to draw the droplet artistically. Just draw an outline of its shape so that you can compare its shape with the shapes of other liquids. Right. Are you ready for us to examine the shapes of other 4 liquids?
Here is a droplet of cooking oil on the glass slide. Draw its outline shape in your table of results. And now we are transferring a droplet of glycerine onto the glass slide. Draw the shape of the droplet.
Let's go on now. Here's a droplet of acetone. Draw the shape of its droplet in your table of results.
And finally, a droplet of methylated spirits. Draw the shape in the table. Methylated spirits is a mixture of ethanol and methanol with purple coloring added to it so that you can easily recognize it.
That's it for the surface tension results. Once again, you will find questions about this part of the practical investigation to answer later. Now, we will move on to investigating solubility of solids in different solvents. Just a reminder, the solute is a substance which dissolves in the solvent. In this case, the solute is brown sugar. The solvent is distilled water. We stir the sugar to help it dissolve more quickly in water. In this investigation, we will use 3 different solvents: water, ethanol, and chloroform. These 3 solvents are very different from one another. Water and chloroform are polar solvents. Ethanol can act as a polar and nonpolar solvent.
Our solutes are sodium chloride crystals, potassium permanganate crystals, and iodine crystals.
We will add the same amount of each solute to a measured amount of each solvent and stir it a few times.
Then we will describe what we see and decide whether the solute dissolved, partially dissolved, or didn't dissolve in the solvent.
On your worksheet, you will find a table for you to record the observation of this solubility experiment. Let's begin.
First, we will set up samples of each of the 3 solvents. We will add 50 ml of water and ethanol to these beakers. We will only add chloroform to a beaker when we need it. Chloroform is a very toxic and volatile substance.
Now, we add the same quantity of solute to each of these beakers. We will try sodium chloride first. If the solute dissolved completely, it will no longer be visible in the beaker. It would have disappeared entirely. We won't see any crystals of sodium chloride in the mixture. If none of the sodium chloride dissolved, we will see it at the bottom of the mixture. It will separate from the solute and precipitate out of the mixture. If some of the sodium chloride has dissolved, there will be less of it at the bottom of the beaker. So, let's start.
We have measured the same amount of sodium chloride in the tiny test tubes. Now we are going to add sodium chloride to each of the solvents. Each mixture is going to be stirred 4 times. Let's get the chloroform into its beaker. Here goes the chloroform. I'll start to stir. 1, 2, 3, 4. Into the ethanol. 1, 2, 3, 4. The last one, the chloroform. 3, 4. I think that should do. And now we wait a couple of minutes for the solute to dissolve or to settle out of the mixture. Sodium chloride in water in our first beaker. Well, I guess you guys can describe what you see here. Write your observations in the table.
Leave the last column blank for the moment. You will complete this table of results when you complete the questions at the end of the video.
Here is the result for sodium chloride added to ethanol. Describe what you see in the beaker. Write your description in the table.
And now we move on to the last solvent, chloroform and sodium chloride. Take a good look at it and write down your observation in the table.
We're now going to remove this set of beakers from the desk. Right, now we change the solute, and this time we'll use potassium permanganate crystals.
We will use only a few crystals of potassium permanganate in each beaker. If we use too much, it may form a solution which is so dark in color that we won't see whether there are any crystals left over.
We will now add 50 ml of chloroform to the first beaker over here, the empty one. Let's give it a stir.
Okay.
1, 2, 3, 4. This one, the ethanol. Give it a stir. And finally, the chloroform. Now we're going to leave these alone for a little while.
The crystals of potassium permanganate are dark purple, almost black in color. We should be able to see them quite clearly in this colorless solution.
Now let's have a look at what happens in the water. It's a very pretty color. And what about in the ethanol? Make sure you write down your results.
Here's the result for potassium permanganate in chloroform. Write your observation in the table.
We are now going to remove all 3 of these beakers so that we can get ready for the next solvent. The last solute is iodine. We're using iodine crystals which are also dark grey in color. We only need 2 or 3 of these to find out if iodine dissolves in these solvents.
That's likely to, as pure iodine is quite an expensive substance. Right, we've set up 2 solvents in their beakers. We will add chloroform later.
Add the iodine to water and stir 4 times, and we'll let it stand for a few minutes. We'll do the same for the ethanol. And finally, we're going to add chloroform to the beaker, and at the same time, we'll add the iodine. And give it a stir.
Let's look at all 3 mixtures together this time.
Okay, there's some changes in all 3 beakers.
First, we have iodine in water. Second, we have iodine in ethanol. Finally, iodine in chloroform.
I'm now going to remove the mixtures from the desk.
There you are. Those are the results of the experiment, 3 for these substances. We have finished our investigation on solubility. The 4th experiment is about comparing the boiling points of water, glycerin, acetone, and ethanol. We're writing this investigation slightly differently. will give you the boiling points of 3 substances. Then we put those substances into test tube marked A, B, and C, and you will identify each of them when we heat them to their boiling points.
Take down the boiling points of these substances. Glycerine has a boiling point of 290 degrees Celsius. Acetone boils at 57 degrees Celsius, and ethanol boils at 79 degrees Celsius. Acetone and ethanol are highly flammable, so it's unsafe to heat them directly with an open flame. We'll put the same amount of each substance into each of 3 test tubes and heat the test tubes in a beaker of water. The beaker of water acts as a water bath.
Here's our apparatus for this experiment. Let's include a digital thermometer in the beaker so we know what the temperature is when the liquid begins boiling. Take care while interacting with the fumes of acetone and ethanol. They could make you drowsy and they are toxic. Let's start heating the water in the water bath. Remember, we're looking for the first liquid that boils and then we can identify it.
Record the observations for these 3 substances in their test tubes. Right, the water is boiling. You have sufficient information to complete this report on boiling points now.
We wish you success in this task and hope that it helps you understand a little more of why it is important to know about the forces between molecules.